In our digital world, it's all about speed and scale, right? And those old school one-size-fits-all databases, they just they can't hang anymore. So today, we're going to crack open the modern data architect's toolkit and explore the specialized, high-performance NoSQL tools that power the most demanding apps we use every single day.
I mean, really think about it. Ever wonder how your favorite streaming service just knows what you want to watch next? Or how your online shopping cart remembers exactly what you put in it, even days later? It kind of feels like magic, doesn't it? But it's not. It's really about a huge shift in how we handle data, all about using the right tool for the right job. So, the secret? It's not some magical super database that does everything. The truth is, different apps have completely different needs. So, what developers have now is this amazing toolkit of specialized NoSQL databases, where each one is engineered to solve a very specific problem and to do it with just incredible efficiency. All right, so here's the plan for this explainer. We'll kick things off by understanding the modern data challenge that made this whole toolkit necessary in the first place. Then, we're going to unpack 4 of these essential tools: key value for pure speed, document databases for flexibility, column stores for big data, and graph databases for understanding connections. And then we'll wrap it all up by looking at how you actually choose the right one for any task.
Okay, so what is this modern data challenge we're talking about? Well, it all comes down to 2 things: massive scale and split-second speed. And that brings us to our very first tool, the absolute speed demon of the database world, the key value store. Yeah, if you need lightning-fast access to simple data, this is your guy. The best way to think about it is like a code check. You hand over your ticket, that's the key, and you get your code back, that's the value. It's simple, it's fast, and it's incredibly efficient. This is really the most fundamental type of NoSQL database out there. It's all built on this super simple but really powerful idea. You have a unique key, let's say a user ID, and then you have a value, which is just the data you want to store, like all of that user's profile info. There are no complex tables, no crazy relationships, just a direct, insanely fast lookup. Okay, so where does all that speed actually come in handy? Well, think about any task that needs crazy fast reads and writes for pretty simple data. Things like storing items in a shopping cart, or managing user sessions on a website, or, oh, a real-time gaming leaderboard. All of those are just perfect jobs for a key value store. And if you want a great real-world example, look no further than Amazon's DynamoDB. I mean, this thing is built to deliver performance measured in single-digit milliseconds at pretty much any scale. That's why it's the engine behind some of the biggest applications on the entire web. But what happens when your data isn't so simple? Well, that brings us to the next tool in our kit, the document database. So if the key value store is our super fast code check, then think of a document database as more of a sophisticated digital filing cabinet. Each file in this cabinet can hold really rich, complex, and even nested information. The absolute keyword here is flexibility. See, data gets stored in these things called documents, and they often use a format you've probably heard of called JSON. And all that is, really, is a way to organize data in a simple, human-readable text format. What this means is you can store all the information about one single thing, like a product with its reviews, its different prices, and all its specs, all of it together in one self-contained record. And you can see how this would be perfect for the back end of a website's content management system, right? Where different articles have different fields, different authors. Or think about huge e-commerce catalogs where one product might have totally different features than another. Each one can just be stored neatly in its own flexible document. And the biggest name in this game, the one you've probably heard of, is MongoDB. It's pretty much the go-to choice for developers building apps that need to handle data structures that are varied and are probably going to change over time. All right, time to grab the heavy-duty power tool from our kit. This is the column database. When you are dealing with just an absurd amount of data and you need to run analytics on it, this is the tool you reach for. Now, this is a really fundamental shift in thinking. Instead of storing data in rows like you would in a traditional spreadsheet, it stores it in columns. So why on earth does that matter? Well, because if you want to analyze just one piece of information, let's say the average temperature from millions and millions of sensor readings, the database only has to read that one column. That makes it blazing fast for analytics. So this makes it the absolute perfect choice for handling huge streams of time series data, stuff from IoT sensors or stock market tickers. It also crushes it at real-time analytics, like analyzing user clicks on a website or just logging massive amounts of activity data that you're going to analyze later.
A killer example of this in action is Apache Cassandra. This was actually developed at Facebook way back when to power their inbox search. So you know it was built from day one to be just massively scalable and to basically never go down. Okay, our final tool is definitely the most specialized, and honestly, it might be the most interesting, the graph database. This tool, it's not really focused on storing the data itself, but on the relationships between the data. It's the ultimate connection expert. So how does this thing actually work? Well, it uses a really simple but incredibly powerful model. You have nodes, which are basically the things, people, products, places, whatever. And then you have edges, and those are the relationships that connect them, like knows, bought, or is located in. And you can literally see what I'm talking about right here. The circles, those are the nodes, in this case, people named Emil, Johan, and Jim. The arrows connecting them, those are the edges, and they represent the knows relationship. It's this visual model that makes asking questions about complex, interconnected data so unbelievably powerful and fast. And the use cases for this are just huge. I mean, social networks are a no-brainer, right? Mapping out who knows who. Recommendation engines use this to find those connections, like, hey, people who bought this also bought that. And it's a total game changer for fraud detection because it can uncover these really subtle rings of connected fraudulent accounts that you'd never see otherwise. A major player in this space is Neo4j. It's designed from the ground up to make querying these complex spiderweb-like relationships not just possible, but really, really fast. Okay, so we've just looked at 4 powerful and very different tools. The big takeaway here, of course, is that there is no single best one. It's all about, you guessed it, picking the right tool for the job. So let's break down how you'd actually choose. This table pretty much lays it all out for us. Look, if your number one priority is just raw speed on simple data, you grab a key value store. Simple. If you need a flexible, rich data model for something like a product catalog, you're going to use a document database. If you're doing massive scale analytics on specific chunks of data, the column database is your workhorse. And of course, for understanding those deep, complex connections between things, nothing, and I mean nothing, beats a graph database. And as you can see, each one has its clear advantages, but also, and this is important, its own trade-offs. And that right there is really the core idea of modern data architecture. The best engineers, they don't go looking for the one best database. No, they take the time to deeply understand the problem they're trying to solve, and then they select the specialized tool from their toolkit that is perfectly designed for that specific task. So this all leaves us with a pretty fascinating question to chew on. These tools we've talked about, they all evolve to meet the data challenges of today. But as our data gets even bigger, even faster, and way more interconnected, what new problems are waiting for us just over the horizon? And maybe more importantly, what new tools will we have to invent to solve them?